without further ado, welcome to the Cannabis Data Science meetup group for October 13th. Hopefully you're all doing fantastic. As always, here to have a little fun, talk about cannabis data, and see if we can discover some insights. So, I'm going to go ahead and kick off the presentation. All right, we're going to do a little, novel analysis today. So we're essentially picking up where we left off last week. And we were doing a market analysis of Massachusetts. And last week we estimated the prices, and we were going to see if we couldn't have a rough estimate of profits. So to just show you some macroeconomic material here, here are some notes that I've written on macroeconomics that you can find on my website. Nothing glamorous here, just a recap of some economics. And welcome to the meetup, Heather. Welcome, Heather. We're just going over a recap of some of the economics we've touched on. Then we're going to dive into the Massachusetts data, and then we're just going to keep extending. If we finish with Massachusetts, I've already lined up a couple of data sets coming from California that we can start to wrangle. So we're just going to keep calculating these economic statistics state by state until we can eventually calculate the aggregate economic statistics. In this case, we're doing a market analysis of Massachusetts, trying to discover the prices, and then we can begin to perhaps estimate the profits of the companies. Pitfall, I realized that the economic models, when we're estimating the competitive prices, assume that profits are zero. So this may not necessarily pan out, but we can give it a shot. So, long story short, we're just going to copy some of the code from the prior weeks. Right. And then we're going to get the data. Welcome, Jessica. We're just doing a bit of just some crude analysis of some data in Massachusetts. So,
great.
Welcome to the group.
Thank you.
Well, I guess just to give you a bit about us. So, I started the company Canalytics, and what the main focus that we do is data analytics of cannabis data. And so we've started this group, and essentially each week we wrangle some data and calculate some statistics. So if you're welcome to share a bit about yourself to the group if you'd like, but that's entirely up to you.
Sure, no problem. I actually just came across your guys' meetup this morning. I recently started a data analytics bootcamp with Springboard. So my career background is 20 years of marketing and sales, but within those positions, I've always done some types of KPI reporting and things like that. So I'm now getting certified and learning Python, Tableau, Power BI, things like that. But again, early stages of those programs, pretty efficient in Excel analytics. So I thought this would just be an interesting meetup just to sit in, kind of observe, maybe make a few connections and go from there.
Awesome.
Program through?
I'm sorry?
Where's your program through?
It's an online program called Springboard. It's powered by Microsoft.
Thank you.
Yep.
Microsoft, okay.
Well, excellent to have you. You're in the right place. So
Fantastic.
essentially, we're just beginning. So essentially, I've just read in some Python packages here that we'll be using. And essentially, we're going to be using the Socrata API to get data from Massachusetts. So, for example, we'll be working with this data set here. So there's documentation about how you can get started and how to get an API token, which is optional, and then the fields that we'll be working with. So long story short, we'll be making a request to the API, so this URL, and we'll essentially just start by getting this production data here. And these are the variables we're working with. I simply define them here just so that they're easy to see. We can see the last 5 observations. If you want to look at the last observation, you can turn that into a dictionary. And so we see, okay, we've got data through October 12th, at which point there were 127,000 mature plants, so on and so forth. And we can even see sales. So this, I believe, is cumulative sales. So we can essentially calculate daily sales by simply taking the difference from day to day. So that's the first data point that we're adding. So now we can actually look at the last observation and see, okay, on October 12th, there were about 5.5 thousand in sales in Massachusetts. There are a couple outliers here that we just need to clean up. So sales that are much higher than believable, as well as negative sales. So those may have been adjustments that happened. Next, we're just going to aggregate the data into, monthly and quarterly series. When you aggregate, there's 2 ways you can aggregate, right? You can either take the sum, so that would be what we're doing when we're looking at sales, right? Because when you aggregate sales, you're looking at the total sales that occur during the week or month or quarter. And when you aggregate something like total employees, well, it wouldn't make sense just to aggregate in some total employees. There, you're more looking at an average. What's the average number of employees at a given point during the month? the same is true for plants and packages, right? You're more looking for the average there. So we'll create these series. Then another Socrata data set here. Is simply the licenses. So these are, you know, the business name, the license type, and there's actually many fields for the licenses. So there's a lot of, you know, rich analysis that you can do here. So for example, let's go ahead and read that data in so that we can take a look at it. So essentially just reading in the licensees here. For the last 5. And here is the last observation. As you can see, we have quite a number of data points. We like to quantify things here, so we can say, oh, you know, what's the length of all of these? There's 51 data points for each licensee. So that's awesome. You know, the more the merrier. They've got some real cool things here. So for example, they already have the address geocoded. So you could already do some interesting plotting on a map. And we've been meaning to revisit mapping. So I'm not sure if we'll get around to it this week, but perhaps if not this week, then maybe in the near future we can start plotting some of these on a map. And then the main data points here that we'll be using are, okay, you know, the license type and simply just the count, you know, how many licensees are there. So 7,500 or 2,750. Awesome. We're doing a market analysis here. So ultimately, we're trying to price everything. And so we priced everything last week, just sort of recapping real quick. And so we're given the price of flour, which is just the average price per ounce. And then we just created a couple supplementary series here just to put this into, okay, so what's, you know, the price per 8? I'm not sure. Yes. And this is something that we noted in prior weeks was, okay, where there's actually missing data here in April of 2020. So that's actually why there's the big dip. So it's not that necessarily that there was, and so this is the unfortunate thing about missing the data there, right? Because clearly there was, you know, a shock during that time. So their data definitely probably fluctuated, but unfortunately, the data reporting at that time is not great. So Yes, we have a conundrum. So we'll just move forward now, just stating that. Okay, so I think we still need some of these data points. So essentially, we've supplemented these data points with just a handful of other data points that are collected by the Federal Reserve here. So for example, we're grabbing the population in Massachusetts, and we're grabbing, the GDP in Massachusetts. And you see here, Q2 of 2020, there is a significant dip here. So perhaps this dip in price is representative of what actually happened. However, we'll show you, if you look at sales, if you look at sales, you'll see that, we're missing sales really between the end of March 2020 and the end of May of 2020. So that's real unfortunate, because it would have been interesting to know what happened with sales during that period. So that's actually an opportune time for, right? So we've been talking about creating value with data and by curating data. And so the people are in possession of that data, right? So if you're a retailer, you may be in possession of your own sales data during that time. And so, wouldn't it be so cool if, all of the retailers could essentially form like a data co-op and, basically say, report, okay, this is what, total sales were during this period in Massachusetts, because that data is valuable and missing, and it exists somewhere. So, anyways, more of that to come. So that's, as you can see, a theme that we've been driving here at Canlytics is, there's actually a lot of value gained by strategically curating your data and getting it into a usable format and supplementing it with other data points, and there's a lot you can do. So long story short, I'm going to go ahead and read in this data in case we haven't already. And that's simply the same data that we're looking at here, except just for the the tail. Right, we're just looking at this segment. So anywho, we've read in this data. Okay, now this is where we were going to start getting into the economics. And so I just wanted to give a bit of a recap here and actually estimate a slightly simpler model this week and see if we can't get a better measure of the rate of return here. So one way we can estimate the rate of return is, okay, so what if So last week we said, okay, there was two parameters, alpha and beta. And this week we're just going to say, okay, it's alpha and 1 minus alpha. And so that restricts the model to having constant returns to scale. So that's an assumption that's built into the model. So that's not great. Well, that's a subjective statement, but it is another assumption built into the model. It's a simpler model. So we're just going to be estimating one parameter now. We're just going to be estimating alpha. So, and the way we do this is we basically just divide the whole equation by, so here n is labor. So if we just divide everything by n, the n is, 1 to the 1 minus alpha is 1. So that n disappears. And then you're just left with kt divided by alpha to the alpha and yt divided by nt. And then if you take the log of both sides, so this is called log linearizing. So that way you have a linear equation that you can estimate. Then you have the log of output per labor, and that should equal a constant plus alpha times the log of capital per labor. So this is sort of our theoretical framework for estimating alpha. And then, yeah, go ahead and just show you the rest of the economics. So I'm going to open this in another tab so that way I can keep this spot. So the reason we want to estimate alpha yes, because so, given this model, right, where we've got, right, so production is now going to equal capital per labor to the alpha. So this K is capital per labor to the alpha. So output equals capital to labor to the alpha. So if capital should get paid its marginal product in a competitive market. So if you take, so the marginal product of capital is the derivative of the production function with respect to capital. So if you take the derivative with respect to capital, so that's going to be the derivative of k to the alpha to the k. So that's just going to be, okay, the way you do this is, right, you bring the exponent down in front, alpha times k to the alpha minus 1. And that will be the marginal product of capital, which will be the rate of return of capital in a competitive market. So this is what we're boiling it down to. So we're basically going to say, okay, the rate of return is going to be alpha times K over L, capital per labor, all raised to the alpha minus 1. So that's the theoretical framework that we're going to use to estimate the rate of return here in Massachusetts, because I wasn't satisfied with how we did it last week. So we're going to use a slightly simpler model and see what our estimate is. So that's the theoretical framework. And so now we're going to estimate it with the data. So we can define our variables first. So right out of the gate, we're just defining Y as sales. And we're going to be working with the monthly series here as we'll see with well, we may not necessarily need to work with. Let's actually work with the daily series here and just kind of do something a little out of the box here. Here we're going to estimate the competitive rate of return in Massachusetts. Okay, so similar analysis as below. Uh, well, yes, let's go ahead and try it, and we may just have to do some data cleaning along the way, but you know, that's the way we do it here. We know we just have to sometimes do this. So let's go ahead and define Y as just production sales, right? We're defining K as just the total number of things that are tracked. And in this case, we were defining labor as hours worked, but now wait, let's just use just the total number of employees. I think it would just introduce less abstractions, and we can use the daily series. So we'll just say labor is just the number of employees. This is the part that was giving me pause, is we actually now need to exclude missing observations here, right? Because, so, you know, say we define our variables. Labor is fine, except the quite confused about this sudden increase at the end. Interesting. That's right. So I'm real. This spike here at the end of capital and labor are giving me quite the pause. And I also essentially want to essentially drop this whole time period here where we're missing sales. So how are we going to go about doing this? Well, let's find the periods where we're missing sales, right? So this is going to be Y, where Y equal to 0, perhaps. Let's list missing sales. We don't necessarily want to just drop any days that are just missing sales for a good reason. So it looks like, there's not really sales through November 22nd of 2018. Looks like they're missing sales on Christmas Day. Looks like, and then so this is the period I was primarily worried about. March 26th, 2020, missing sales through May 5th, 2020. And then, it looks like there's a scattering of other days that they're just maybe missing sales for one reason or the other. So just for the sake of time here, I think we're just going to exclude all the days that are missing sales. However, that may not necessarily be, the best practice.
Because if it's closed, you can't eliminate that data. I mean, you'd be creating data where it should not exist, right?
Can you say that one more time, Heather?
Like if the store is closed, some places around here, they're definitely open Christmas Day, Christmas Eve, or whatever. But if something is truly closed, inserting the data would not be allowed, right?
Well, it's more just it appears for that day we're just missing an observation. So maybe like the office was closed and then they just entered the data in on the 26th or what have you. My main thing is just don't want to include sort of these oddballs in the analysis. Because sort of like when we're running a regression, if our output is 0 and we have a certain number of plants and employees, well, that may sort of bias the model in one way or the other when the sales weren't in fact 0 is sort of my worry. So I just thought, okay, to avoid introducing bias for days that are coded as 0, but they're not actually 0, then I was just going to ignore those days. So, luckily, we're given, a little more than 1,000 days here. So essentially, I was just going to exclude, these 97 days from the analysis and saying, okay, these days aren't your typical day. So let's just do our analysis on, your typical day, so to speak. So I hope that answers your question, Heather, but please chime up if you still have concerns.
Nope, thank you.
But it's just sort of a step that I'm taking to try to remove outliers that may not be representative of the normal. So long story short, just going to get these where we're not, missing sales. So let's see if we can't just exclude those sales. Well, that may not have worked.
Oh, Keegan, I'm sorry, I see my question now. Okay, so when excluding data like this, like so for example, when I was fitting like crystal structures to the model or whatever. Like it didn't always fit right, but then there are points that I could eliminate because the light beam did not actually hit there, even though the light beam was there. So it's like when you eliminate data in this case, it's like data you're supposed to have, but that's not there, or data that's truly not there. It's a very theoretical thing, but I'm not sure that I'm maybe understanding it right.
Oh, well, in fact, there's a whole sort of, so in econometrics, they'll do studies about, okay, you know, what happens if there is measurement error, or, you know, what happens if you do exclude a subset of data, and what happens if the subset you exclude is non-random. And so long story short is, yes, it does introduce bias. And so yes, if you just exclude a segment of the data like we're doing now, or if you were going to have measurement error. So if we're going to, it's basically like you've got the bias one way or the other. So you've either got
Right.
measurement
Right.
error, where these days are coded as 0, and they shouldn't be, or you've got selection bias potentially, where we're just selecting a subset of the data for analysis. And by doing so, we may be introducing bias, because you're right, there may be something special about the days that we're excluding. So
Thank you. Thank you. I think that's well said, because it's like it tells you how you can interpret this data. Because at this point, like as of yesterday, last week, I wasn't sure if the model was right, because alpha and beta being completely out of range. Like when something's completely out of range, it usually means the model is wrong.
True. Or, well, we had a wide confidence, and we had a small number of observations, so we couldn't really say with much confidence what the parameters were going to be. So true. Ooh, another potential we could do is we could potentially, instead of just excluding the missing sales, we could potentially just look at this, you know, just from the last year. But then again, you know, it's saying, okay, well then you know we're excluding all the data from before last year. So that's just a quick way to wash your hands of the problem of selection. And
I'll
so,
be sure to do that with everything in my life. Thank you so much. It sounds great.
so long story short, we're kind of stuck between a rock and a hard place where, and this is where I like to, you know, stress to people, you know, really, like when you see someone present their data, definitely ask these hard questions and push them on these, because, you know, when you're doing any sort of data analytics, you run into these sort of conundrums, and, you know, a lot of the times these solutions get done, you know, behind the scenes, and they may not get talked about a lot, right? So like in our analysis, we've got this missing data gap, and, you know, that may not necessarily be, you know, readily apparent in whatever statistics we end up calculating. But good point. And my only comment is just to power on. So it's just sort of present your biases, just acknowledge them, be upfront about them, emphasize them, and then, so, you know, not necessarily, but I'm under the belief that some statistics are better than no statistics. So we'll at least try to measure the alpha so we can get the rate of return of capital. So we're going to hedge it that it may be just wildly inaccurate, but we're just sort of going to try to calculate it for a curiosity. But real quick here, having a bit of trouble excluding these missing sales. So I may have to resort to pandas real quick. So 1 second. So let's see if we can't solve this real quick. Index. Aha. Well, okay. This may not be the end of the world because I think maybe the plot's just off. So, okay, great. So this worked out okay. Um, the plot was just confusing me. Okay, so long story short, we're just going to try this real quick. YKL. So now we can actually define, right, output per labor. So that's Y per L. And then we're going to define output per capital. And then let's just plot them just to see what these look like exactly. This is output per labor in the last 300 in the last year. So what the nominal number means, I'm not certain, but we've got our fluctuation and capital per labor is increasing. So that's quite interesting. So um, per per labor variables. Next, we're going to be essentially trying to estimate alpha here, right? And so remember, we have to log, right? So here we have to take the log of both sides. So log y and then we can find the log of capital. And we can essentially run our regression here. Oh, that's right. And we just have to add a constant, right? Because we have our constant term, which is technology, right? We've got a technology augmented production function. So let's just add a constant here. All righty then. This should not sure why we're getting a bad syntax error, but oh, we've got double equal signs. That would make sense. All right, it looks like the regression was fit. But maybe it was not fit. So it looks like something went wrong here. Okay. I bet you may have some, exactly, see here with, whenever you take the log, if you take a log of a negative, you can't take a log of a negative, right? So we've got some missing values for y here. So why is that? Okay, so that's right. So, oh yeah, that's because we're missing sales on October 15th because we had to do the difference. All right, so there's several ways we can do this here. So we could either just exclude the first observation, or we could start at a specific point in time. And so could potentially do both. So here I'm just going to exclude just the first observation because it looks like the first observation is missing for sales. So that may not have quite done the trick. Interesting. Okay. So it looks like missing values here for the log of capital per labor. So this is a mess. So what I'm going to say is, okay, we're just going to whatever was going on in this period, October 15th to it looks like about, the 20th of November was not consistent. So yet again, we're going to exclude values, which, as Heather pointed out, introduces bias, right? Because there may have been valuable information in that time period. But because it's just so messy, we're just going to have to restrict our data to after to the 20th or after. So how are we going to do that? Well, simple enough. So we basically want all values of y where the index greater than or equal to a specific date. Don't promise this is going to work, but it looks like it may have. And so then we basically just want to repeat this for capital and labor. And then we don't have to restrict it to the first day anymore. Okay, so maybe now, but now again, now I've gotten real uncertain about things. And in fact, we just estimated a negative value for alpha. So this something went wrong. But that may be for the best. So let's see here. So log y. So our analysis may have gone haywire here. Unless we just have well, for some reason, and so, this is where I kind of just want to say, we may not want to just keep playing, code pool here, and, we may just not have, successfully estimated alpha in this manner. And that may be okay, because, last week, we saw, there's one more thing I'm going to try, but, last week we saw that if we estimated this with two parameters, alpha and beta, we didn't have a constant returns to scale. We had decreasing returns to scale significantly. So it may be that this assumption, this assumed production function with constant returns to scale is not adequate for representing the market. Before we give up, the last thing I wanted to try was, okay, let's just try doing this, let's just try after May of 2020. So let's just start in June of 2020 and just see if we start at this time, if the data is just a bit more, less outliers. No promises, so let's just see. And let's also just say, we'll just try it with this before we. And this is, yeah, like I said, I think this analysis is just going to need to get tossed out, because basically, once again, incredibly low R squared, so we're not really explaining much of the variation. Not really a significant coefficient here on alpha. It's close to 1, which is not really value that you would expect for alpha. So I hate to have just run us down this rabbit hole here, but sometimes this is constructive. Just to see, we attempted to estimate this model here, but I don't think we successfully did. And so that's okay. And Jessica, just to show you essentially what we estimated last week and why this may have broken down this week. So last week we were looking at the monthlies, and that's the other thing we could potentially try is, what happens if you measured labor in terms of, hours worked. And so, last week we looked at labor in terms of hours worked, on a monthly level. And so here we're estimating this same function, except we're letting 1 minus alpha be its own parameter, beta. And so then we're log linearizing and saying, okay, log y equals log a plus alpha log k plus beta log n. What we find when we do that is yes, an alpha of around 0.2, a little less than 0.2, and then a beta of around 0.45. So that's, if you add those together, that's less than 0.65. And so they would need to sum to 1, for there to be constant returns to scale here. Right, because that's what this model is, right? So if we assume that this is alpha, then 1 minus alpha, those have to add to 1. And then in this case they don't. So what that means is we've got decreasing returns to scale. So that would violate the assumption of constant returns to scale.
Very cool.
Can you say that one more time, please?
Oh, no, I said thank you. That was just really helpful to see what you guys did the last time.
Oh, yes. Because oh yeah, the derivative would be different. All right, so that was sort of a curveball. Sorry, well, maybe that was the lesson learned today, that things don't always go as expected, because I was just essentially expecting this to pan out and then compare the rate of return to what we estimated last week. And so last week just in the last 12 months. So last week we tried to estimate, the rate of return, essentially per plant. So this would actually be the cost per plant, or, what the investor would expect to get paid per plant. And this was with our first model, and so I was hoping to estimate it again with this second model and compare the two, but we were unable. So basically, we've tried a couple different models now, and it seems that the only way that we're able to is monthly with, the number of employees, labor proxy as hours worked, and capital proxy as the number of plants. And, I would, put a serious hedge on these numbers, but, this is about, the best we could do, or the best I could do, with the data given. So, so I think I'm going to think about this the next week, because I was wanting to kind of try to tidy things up today, and I think I essentially just uncovered more loose ends. Um, so so perhaps for next week we can finally start to really hammer this down, or turn directions to California or another state. But and then that's another thing is I'm also going to ask a couple, actual growers, what is your, cost per plant? Is your cost per plant, around $100 or so? Like, does that sound reasonable? Or, is, $500 per plant, is that out of the ballpark? So, so that's another thing, is I can start to actually try to get some anecdotal evidence to see if that could support some of our empiric evidence. So, so, so completely dissatisfied with the analysis for today, but that's probably for the best, right? Because it shows, what needs to be, touched up and re-looked at next week. But if any of you are interested, there's a lot more macroeconomics here to be had. And then for next week, there's some interesting California data. So, there's, sales by county. So we could start looking at, an economic analysis of California. So we don't have as many data points here, so it may be tough to make any statistical determinations of any sort, but there's data to be had. So, until next week, I'm sure I may have left some of you unsettled with some of the analysis today. So if you've got any questions, feel free to reach out, and yeah, we can continue to, think about and puzzle out this data, and if any of you have any inputs, definitely, always open to, new statistics that you may be interested in having calculated. So, but it's a look behind the curtain, right? Because it's it's things don't always go as planned, and I think today was a good example of that. So you saw firsthand where we tried to go off road and calculate the daily rate of return, and it wasn't fruitful. And I do kind of want to apologize for that, but you can't always force an outcome, right? Right? If we tried, we tried dropping the missing observations, and there's still more things that can be tried. So by all means, I would recommend to you to repeat the analysis, but instead of using the total number of employees, use total number of hours worked, so you can estimate that. All right. Yeah, we'll go ahead and jump off. But long story short, thank you all for attending, and I hope you learned something, and be in touch, and we'll pick up next week. So, all right, all. Thanks again for coming. Thanks for attending the Cannabis Data Science Meetup group. And until next week, keep your nose to the grindstone and keep having fun.